Slide number 3. Sometimes we need to construct foundation for your project. We learned how to design column, but how we can connect this column to your soil by something called foundation. We have different shapes of foundation. Maybe every column has footing, so we can call it isolated footing. Your reinforcement just mesh in 2 dimensions, in X dimension and Y dimension. Just a reinforcement mesh, one layer, only one layer of reinforcement. So the first type of your footing, of your foundation, called isolated footing. Each column has its own footing. As you see here, this footing, we need to know few things. What is the dimension of your footing? Looks like a rectangular shape. What is the total depth of your footing? How much is the reinforcement at the bottom of this footing, in this direction and this direction? If you would like to design your isolated footing, I need answers for all of these questions. What is the dimension of your footing? Width and length? What is the total thickness? How much is the reinforcement at the bottom of your footing in this direction and this direction? One student will ask me, what about your column? We did our design of column. Just a quick hint, in the concrete exam, at the beginning of the exam, do you remember what announcement I did? I told you there is no torsion in the exam. That's happened?
Yeah.
I have many answers, right, torsion. So when we start to design isolated footing, we will answer all of these questions. Okay, I have 2 columns in your building, and I design isolated footing for this one and isolated footing for the other one, and I found something not good. This column and the other column, I'm talking about plane. So this footing for this footing, for this column, and the other footing, we have overlap between the two footing. So the other option, or the second option, something called combined footing. Okay, these 2 columns are very close to each other. For some reason, I bought 2 columns very close to each other. I designed first isolated footing for this one and isolated footing for this one. I found your footing overlapped. So I will cancel my first option and I will start to design something called combined footing. Combined footing, something like this. Only one footing supporting your 2 columns. So we have 2 columns supported by this footing. But remember, I cannot decide to use combined footing until you try isolated footing first for each column. If you have overlap in between, then I decide to use combined footing. Any questions so far? Any question? This one is more complicated because you have to try first isolated and then take a decision for combined. Third type of footing called strip footing. If you have wall, so if you have only one concentrated load or one column, yes, I can construct one footing like this. But if you have continuous wall, so I cannot construct only one footing, another footing, another footing. No, your footing will be strip footing. something like this. If you have concrete wall, if you have brick wall, if you have any type of wall, fence, you can construct strip footing underneath your wall. The third one, or the fourth type of footing, called strap footing. I forget something. If you have isolated footing, here is your elevation, and here is your plane. You have to put something in your mind. The centroid of your column, I will not say must, but should be the centroid of your column, of your footing. So centroid of your column will be the same like centroid of the footing. Any question? Sometimes, if you have neighbor, okay, let's talk about this point. It's very important. Here is your area property, and you would like to construct your house. Here is the street, and you have column at this location, and you have column at this location, and here is your neighbor. You have column at this location. Here is another street, and you have column in this location. What do you think? Okay, for this one, I can construct my footing like this. The centroid of the column at the centroid of your footing. One will ask me a question. Do you think I can put something in the street? Yes, you can, because your foundation underneath the ground surface. You can put your, you can excavate and put your foundation and then put your soil. So after you are done, nobody will see anything in the street. That's right? So I can. That's right. I can do this. But I cannot put anything at my neighbor's property. So how can I put my footing here? The only option to put your footing like this. I cannot put anything over the ground or underground at my neighbor's property. That's right? What do you think? What is the difference? Okay, let's see elevation for this shape. You have your column and you have your footing, something like this. Your column has a concentrated load P ultimate. Do you think this load will make something for this footing? What do you expect? Overturning. Like this chair. If you stand at the centroid of this chair, nothing will happen. But if you stand at the edge, overturning. We have another column inside your belly with regular footing. So I will connect between this footing and this footing with a beam. This beam called strap. So I will connect this footing with another footing and another column inside your property. So if this column would like to overturn this footing, this strap will connect between this one and this one. This is the idea for strap footing. Like this. For some reason, maybe this one will be also on the street. Maybe you don't have choice to put your footing in the street. No way. So I will put my footing at the edge, like this. So I have to connect between this footing and another footing with something called a strap. So if you don't have option to put your column at the centroid of footing, and you have to put your column at the edge of your footing, we have to connect between this footing and this footing by something called strap. So this is the shape of your strap. Can you see? This column, this footing, the column at the centroid. But this footing, your column at the edge of the footing, so we connect between this footing and this footing by strap. So do you remember we have 4 types of footing? First one, isolated. Each column has its own footing. Second type, combined footing. 2 columns in 1 footing. Third type, called strip footing. If you have a wall, longitudinal wall continuous with you, so we have to put a strip footing. Sometimes we have strap footing if your column at the edge of the footing for some reason. We cannot put this column at the centroid. So your column must be connected by strap. Any question so far? Any question? We have another type of foundation called raft or mat. Raft or mat can be written like this. Mat foundation. All of your column in your building supported by one big footing. But at this time we can call it footing. We can call it raft or mat. Something like this. As you see here, the whole building, the whole columns in your building will be constructed on one raft. Your raft like something looks like slab with double layer of steel reinforcement, but your depth is very large, not 4 inch or 5 inch. No, it can reach maybe 20 inch, 30 inch, 40 inch, based on how many floors do you have. So, raft foundation, only one slab, but we can call it slab, we call it raft or mat, supported all of your columns in the building. The steel reinforcement, double layers, top and bottom steel reinforcement layer in each direction to reinforce this slab. The last type of foundation called piles. Did you hear about piles before?
Yeah.
Piles, we have a big issue. What's the issue? Here is your ground surface. Do you know something called boring? Boring. No. Okay, you will hear all of this stuff next semester with Dr. O in soil mechanics. Boring, we have some people coming with this excavator trying to reach certain depth in your ground to take samples of soil. Maybe you can reach 10 feet, 20 feet, 30 feet, 50 feet, 100 feet, based on what type of foundation or what type of building. So I can tell you, hey, the first maybe 10 feet of your soil construct of clay. Then we have another 20 feet, what's called? Sand. Then we have another 25 feet gravel. Then we have rock. And we need to construct building for 100 floors. So 100 floors, we need to reach what's going on inside the soil. If you construct your 100 floor on clay, failure will happen to your soil. Sand, the same. Gravel, the same. The only layer that can support this heavy load from 100 floor is your rock. But it doesn't make any sense for me to excavate around 55 feet for the total area of your building. So we have another option. We can construct column. But at this time, these columns embedded in your soil. So we can call it not column, we can call it piles. What is the main purpose for this pile? Here you can construct your footing, and your footing supported your column. So the load coming from column supported by this footing, which called pile cap. I can call it footing because footing should be supported by soil directly. But this one is supported by piles, so we can call it pile cap. Then the load coming from pile cap to piles, this pile will transfer your load to the soil layer that can support this huge amount of load. You got it? This type of foundation called deep foundation. Deep, we need to reach something very deep inside your soil. Here is the shape of your piles. I cannot see it because it's embedded in your soil. How we can construct these piles? We have many techniques to construct these piles, but this is not our topics in this course. So we constructed embedded column. Then your column will support something called pile cap, and your pile cap will support your superstructure or columns after that. We have two shapes. Maybe we have raft supporting the whole columns, and this raft supported by many piles embedded in your soil. Or we have each column has one pile cap, and this pile cap supported by few piles. We have another pile cap there, we have another pile cap there, we have another pile cap there. So